Welcome to PHYS2120. In this video, we are going to look at another example of how to apply Coulomb's law to three charges which are aligned linearly. We have Q1, which is 2 millicoulomb, and Q2, which is 4 millicoulomb, and Q3 is 1 millicoulomb. It's negative 1 millicoulomb. And they are all, Q2 is at a distance of 4 centimeters from Q1, and Q3 is at a distance of 8 centimeters from Q2. We want to find the net force on Q2 due to Q1 and Q3. This is how a free body diagram will look like. I have chosen my coordinate system such that the positive x-axis is on the right and the positive y-axis is up. So all the forces that will be pointing towards the right will be assigned positive, and all the forces that will just point towards the left will be assigned a negative force. The free body diagram is like this. The force of Q1 on Q2, they are both positive charges, so they will repel each other. We have F1 of F2 acting on Q1 in that direction. From Newton's third law, the same magnitude of force will act on Q1, but we are not interested in this. We are interested in the force that will exist, the net force that will act on this. For Q1, the force that is acting Q2 by Q3 is attracting, so pulling it towards this direction. And the force of Q3 on Q2 is also attracting, and it's pulling it on that direction. So we have F1 of 2 and F3 of 2 all pointing in the same direction. The net force on Q2 will be the sum, the algebraic sum, the vector sum of F1 of 2 plus F3 of 2. If we want to find the magnitude, we apply Coulomb's law here. K is a constant, we have Q1, we have Q2, and we have the distance between the charges. Remember, always change your unit to the standard unit, the SI unit. The distance is in meters. Here we have it in centimeters, so we will change that into meters. The coulomb or the charge is in millicoulomb, so we will change that into coulomb. And we know that 1 milli is the same as 10 to the power minus 3. And we also know 100 centimeters is also the same as 1 meter. So in doing so, when we change 4 centimeters into meters, we have 0.4 meters. The same thing applies to 8 centimeters. You will have 0.8 meters. When you substitute all your values into this expression, the Coulomb's law, you have the magnitude of the force to be, for F1 of 2, to be 3.6 times 10 to the power 6 Newton, and for F2 of 3 is also 9.2 times 6 to the power 6 times 10 to the power 6 Newtons. The net force, this is 5, this is 5. This should be 5.6 times 10 to the power 5. The net force acting on Q2 will be adding this and that. Since they are all in the same direction, you just have to add the two forces together. And this gives us 9.2 times 10 to the power 6 newtons. And it points towards the positive x-axis. So this is the net force acting on Q2. This is the magnitude of the force, and that is the direction of the force. Thank you.